So let's suppose the utility function u of ab is equal to max of 3a plus 2b, comma, a plus 4b, okay? Where ab is just a real number, real vector, non-negative real vector. So the question is, find the indifference curve for alternative AB, which is equal to what? 2, 3. And then, for example, calculate the, find marginal rate of substitution at 2, 3. And, well, we can make a bunch of other points, 5, 5, for example. Yeah, let me think. Yeah, well, I don't know. 3, 7. Okay? So let's work on this example. So here, well, first off, let's talk about a simpler version of this question. So this is a utility function which basically takes the maximum of 2 arguments. This is argument 1, argument 2. By the way, this solution is very much similar to the one I solved previously and posted on a course website, but there it was min function. All right, so they behave very similarly. So the simplest version is something like u of ab equals, max of, I forgot the max of a comma b. All right, so this is probably the simplest version. Well, you may try to draw this indifference curve, all right? For example, draw the indifference curve for 1, 1, all right? Well, simple. How do you draw it? Well, I'm not going to do it in detail, but you'll see that, by the way, the first axis is A, the first component. The second axis is B. Do not invent new notation, all right? Always go with the notation given in the question. So we usually put the first component on the horizontal axis, right? So don't put B here, A here, for example. So the indifference curves are going to look something like this, right? Well, again, I spent some time to understand why this is the case. If you have, however, a utility function, u of ab equals min of ab, all right? Everything is the same except the fact that I'm talking about the minimum instead of the maximum. If you drove the indifference curve, which we did, and so I'm not going to talk about the details of it, but the indifference curve has this L shape. So sort of, both have the L shape. I mean, this is not really L, but it's sort of the mirror image of those indifference curves. And so in this direction, also in this direction, the indifference curves will have higher and higher utility. So when I have a bit more complicated utility function like this one, max of 2 arguments, so this is not just A and B, but a combination of A and B in some way, a different combination. But the idea is going to be very similar. Obviously, it's not going to be completely horizontal or perpendicular, but this time it's going to have some angles on both this side and this side. But nevertheless, the idea is going to be, there's going to be some line. It doesn't have to be A equals B, but there's going to be some line where there's going to be kink point of these indifference curves, all right? And then the indifference curves, all right, so there's going to be some line, I don't know what it is, and then the indifference curves will have some angle, and they're going to move in this fashion, okay? So this is what this type of functions look like. If it was min, well, then it's going to be, again, sort of the mirror image of those graphs. This is almost always the case, all right? So knowing this is, well, obviously helpful because you know what the final picture will look like, and so you can always double check your solution whether you are doing something right or wrong. So here, however, how do we solve this formally? Well, simple. Once again, you have to write down the utility function in this form. So utility of AB is equal to 3a plus 2b if 3a plus 2b is greater than or equal to a plus 4b. And then it's equal to a plus 4b if otherwise. I mean, the 3a plus 2b is strictly less than a plus 4b. All right? Once again, spend time to understand this. All right? Don't take it as given. You drive this, at home. So why this is the case, let me give at least an explanation. Well, remember, this is an argument which maximizes two of the arguments. Argument 1 is a straight line, 3a plus 2b. Argument 2 is another straight line, a plus 4b. So whichever is the max, this is why I have the comma. Either take this one or this one, whichever the max, take that one as the utility. So therefore, if the first argument is greater than or equal to the second argument, well, if it is strictly greater than the second argument, obviously the maximum of these two arguments is going to be the first one. So your utility should be equal to this. If they're equal, it doesn't matter whether the first argument or the second argument, they both are going to give the same value anyway. So without loss of generality, you can say whenever they're equal, utility is going to be equal to the first argument. All right? And then if it is strictly less than, however, all right, so let's write this otherwise more openly. Strictly less than a plus 4b. Well, in this case, the maximum of these two arguments is the second argument, and hence the utility function should be equal to the second argument itself. I mean, the utility should be calculated according to the second argument itself. So as simple as this. So once you have this, so this is step 1, let's say. Step 2, easy. Simplify this, right? Because there are a's on both sides and b's on both sides. So let's pull everything on one side. So a on the left-hand side, b on the right-hand side, or the other way around. So if you send a to this side, I'm going to have 2a here. If you send 2b to the other side, I'm going to have 2b. So 2a greater than or equal to 2b. 2's will cancel out. So I'm skipping some steps, obviously. So a is greater than or equal to b. Do I have to make the same analysis? Remember, this was otherwise. So otherwise means what? Well, the sort of opposite of this. So a is strictly less than b. Okay? So you don't have to do the analysis or sort of this calculation again. So that's it. So whenever your a and b satisfy, this, well, this is your utility. If it satisfies this, this is your utility. So question. What is the utility when a and b are 2 and 3, respectively? Well, is a greater than b? No, because 2 is less than 3. So this is true for this particular numbers a and b. So therefore, this is how you should be calculating utility. That means the utility of 2, 3 is equal to a plus 4b. b is 3, so it's 12. So it's 14 units. All right? Well, what about utility of 5, 5? Well, utility of 5, 5, well, what is the relationship between a and b? Well, a is equal to b. So therefore, your utility function is equal to 3 times a plus 2 times b. So when a is 5, b is 5, it means 15 plus 10, 25. By the way, it doesn't matter whether you use this one or this one, remember, when a is equal to b, because both of these arguments are going to be the same. Right? If b is 5, this is 20, this is 5, so 25 again. So I am double checking and see if there's any logical pit hole in my thinking. And what about 3, 7? Well, the 3, 7, the utility level of this point is, well, what is the relationship between a and b? Well, once again, b is greater than a, bro. So therefore, yes. So therefore, I still have this utility function, not the first argument. So once again, it's a plus 4 times b, which means 3 plus 7, 4 times 7. So it's 28, 3, 31 units of utility. All right, so these are the utilities. What about the marginal rate of substitution? At point 2, 3. What's the marginal rate of substitution at point 5, 5, I'm sorry. And what's the marginal rate of substitution at point... So this straight line basically means I am calculating MRS at specific point 3, 7. All right, this is what that straight line means. So here, how do I calculate the marginal rate of substitution at any point? Well, first, what is the utility function at that point? The utility function at that point is not this one. Remember, it's which one? So b is greater than a. So the utility function is this. When a is 2, b is 3. So therefore, when I calculate the marginal rate of substitution, I have to take this utility into account and calculate MRS equals, remember, marginal utility with respect to A divided by marginal utility with respect to B, and then evaluate this at point, meaning whenever I have A, plug 2, whenever I have B, if I have B, plug 3, and then calculate a number. So, well, what is the marginal utility with respect to A? It's 1. So don't forget this minus sign, 1, divided by the marginal utility with respect to B is 4. There is no A, there's no B, which is right, I mean fine, because this is a straight line. It's a straight line, and so therefore its slope is constant, independent of the AB values, as long as AB satisfy this. So therefore the marginal rate of substitution at this point is minus 1 over 4. In fact, same here. Because remember, the 3, 7 is a point where utility function is equal to this one. Well, what about this guy, 5, 5? Remember, 5, 5 is the point where utility function is either this one or this one. So this is the, how to say, kink point. And the kink point is the point where the utility functions, the functions are not differentiable. And so therefore, the marginal rate of substitution here is undefined. Once again, this is because this 5, 5 points is the point where A is equal to B. It's the kink point, and when we draw the utility function, you'll figure out why it is the kink point. And so the function is not differentiable there, and hence MRS, which is this slope of the indifference curve, is undefined. So that's basically the second part of the question. What was the first part of the question? Well, the first part was find the indifference curve, right? Draw the indifference curve. Well, I mean, simple. All you have to do is to draw the indifference curve of this step utility function at point AB equals, 2 and 3. As simple as this. Well, what is the utility level at 2, 3? It's 14. All right? Good. Well, is it 14? Yes. Yeah, I'm just checking. So it is 14. So that means, let me open up some space. The indifference curve of the point 2, 3 is equal to this, guys. 3a plus 2b equals 14 if a is greater than or equal to b, and then a plus 4b equals 14 if otherwise, or just a is strictly less than b. All right, that's it. I mean, as simple as this. Why is that so? Well, I mean, remember, what is the utility? So let's say utility is xy equals, I don't know, x times y. So what is the indifference curve of point 2, 3? Well, it is, remember, according to the definition of indifference curve, all the points x and y's where x times y is equal to, I mean, let's put it this way. So x and y is equal to, the utility of 2 and 3, which is 2 times 3. So it's 6.
Excuse me, sir.
Go ahead.
Sorry. The first line, 3a plus 2b at 0.23, isn't that equal 12?
This one?
Yes.
Okay. For who? For a equals 2, b equals 3?
Sorry, for that line, it's at 0.23. Isn't that equal to 12 instead of 14?
Okay, very good. Yes, it is. So, I mean, your question was, this 3a plus 2b, isn't this equal to 12 when a is equal to 2 and b is equal to 3? And my answer to this is yes, it is true. But I am drawing an indifference curve, remember?
Okay.
I don't want points A, B to be 2 and 3. I want any A, any B, when I multiply them 3 and 2 respectively and add them up equals to 14. Which,
makes sense.
Okay, very good. All right, hopefully. All right. So, by the way, this is not really a formal writing of an indifference curve, maybe a sort of more formal, well, sometimes we definitely allow a flexibility. I mean, we don't really, this is not a math course, so we don't want you to be 100% formal, but there's some sort of a limit, right? So this is not really 100% mathematically correct way of writing indifference curve. It would be something like indifference curve of 2, 3 is equal to, A's and B's in this mother set such that 3a plus 2b equals 14 if a is greater than or equal to b, and a plus 4b equals 14 otherwise. All right, something like this. Okay, there are a bunch of different ways of writing this, but that's sort of the shortest description, and so I prefer to write it this way. Okay, so once again, so that's the idea. So yes, that was a very nice question. Thank you very much. So 3a plus 2b is not equal to 14 when a is 2, b is 3, but I don't care because I am trying to find A's and B's that are indifferent to 2 and 3. What does that mean? That means A's and B's that are going to give the utility, same utility that 2 and 3 does give. So what is the utility 2 and 3 gives? It's not 12, because remember, the utility function when A is 2, B is 3 is utility function is not this one, it's this one. And therefore, the utility of 2, 3 is not 12, it's 14. So that's important. However, there may be some A's and B's or X and Y's, all right? If A, B is confusing you, but it shouldn't really, all right? So if it is confusing you, that's another fundamental issue that you should spend time to understand when there are a lot of A's and B's going on. Sometimes distinguishing it with X and Y's is good, but sometimes is not good, all right? So don't add extra layer of notations. So just try to stick with A and B. So here, because everything, the utility function is given as an A and B. So here, so there might be some A and B where A is greater than B. All right, so here A is less than B, but maybe there are some A and B that are greater, A is greater than B, and when you calculate the utility, which is going to be, the utility function is going to be this one, gives exactly the same utility level, which is 14. Actually, can I pick any number? Yes, for example, A has to be greater than, right? Okay, so B equals 0, A equals 14 over 3, for instance. All right, so this point and 2, 3, 14 divided by 3 is 0. So this point and 2, 3 have exactly the same utility level. So they're indifferent to each other. Okay, and this point, A is greater than equal to B. So it satisfies this. And so its utility is calculated according to this one, not this one. All right, so once again, if you want to draw the indifference curve, or all you have to do is basically draw those lines, all right? And I have like 2 minutes, and I need to stop promptly because I have some students coming to my office hour. So let me just draw the indifference curve. I'm not going to speak about the details of it, but if it is not clear how we draw it, well, you should definitely think about it later. So if this is A, if this is B, well, first off, remember this if A greater than or equal to B otherwise condition. So this condition is basically dividing my mother space. So this is my mother space, R square plus, and I divide this mother space into 2 pieces. A's and B's satisfying the first condition, A's and B's satisfying the second condition. So this dividing this space, the mother space, is this line, A equals B line. As long as A is greater than or equal to B, which is this region, all right? A is greater than B region, and A is strictly less than B region. Oh, this is strictly, I'm sorry, greater than. So on this line, A and B are equal. Below it, A is greater than B. Above it, A is less than B. So remember, whenever A is greater than, strictly greater than B, my utility function is this guy. So therefore, the indifference curve is this line. So draw 3A plus 2B equals 14, which is like B is going to be 7. Let's make this 7. And A is going to be 14 over 3, which is like 4-ish, 14 over 3. So therefore, this is what it's going to look like. I put this dotted line because remember, this indifference curve is not valid above this line. It's valid only below this A equals B line. And then I have, whenever A is strictly less than B, I have this indifference curve. So just draw this, A plus 4B. So when B is 0, A is 14. So 14 is somewhere here. And when A is 0, B is 14 over 4, which is like 7 divided by 2, 3 point something, so somewhere like this. So that means you have to have dots here because it's not well defined in this region, but it's well defined in this region. All right, so my indifference curves curve with the utility, so this is, sorry, I2, 3, when the utility level is 14. Trust me, this is another indifference curve with a higher utility level. This is another indifference curve with a higher utility level. Good exercise is to pick another point other than 2, 3, for example, 5, 5, and draw its indifference curve. All right, and why do I know 5, 5 was on the kink? Remember, A equals B is the kink point always. So 5, 5 is clearly on a higher indifference curve, but it's on the kink. And so whenever a point is a kink point, all right, basically the function is breaking very harshly, not smoothly, and so therefore derivative is not well defined, and hence MRS is not well defined. And 2, 3, by the way, my point, AB equals, my specific point, AB equals 2, 3 is, by the way, so this is, remember, around 4 point something. So this is going to be my 2. And my 3, this is my 3.5. So my 3 is somewhere here. So my AB point is going to locate it here. All right? But again, there's millions of other points, A's and B's, which have different values, obviously, but they always give the same utility level, which is 14. Okay? Any question, guys?